For our last part, we're going to revisit quadratic equations with only one solution. So the other day, we saw that quadratic equations could have 0, 1, or 2 solutions. So we're going to sketch the graph that has no solutions. So remember, a solution is when the quadratic equation touches the x-axis. So there could be several examples here, but let's draw a parabola here. Never touches the x-axis, no solutions. Here's another example, no solutions. Now to have one solution, it would touch the x-axis one time. So like that. I'm going to draw that a little bit better, but it touches just once. Here, touches just once. And then lastly, for two solutions, just touches twice. So now we're going to use graphing technology to graph x squared minus 2x plus 1. So I'm going to press y equals x squared minus 2x plus 1. Graph that. I'm going to press zoom 6. So this, I think it's running out of things there. But if I were to try to factor this, x squared minus 2x plus 1 can be written as f of x equals, that can be x minus 1 times x minus 1. So we could think of that as only having one solution. So if I were to solve that, 0 equals x minus 1 times x minus 1. I would just solve x minus 1 equals 0, or x equals 1. This has only one solution. So we did the zero product property because graphing technology didn't work. We ran out of batteries. So our solution is x equals 1. So write an equation to represent another quadratic function that we think will only have one zero. So I think it's when we have this one solution is when we have f of x equals, let's say, x plus 3 times x plus 3. So if we solve this with the zero product property, this would have one solution when x plus 3 equals 0, or x equals negative 3. Another thing that we could do here to try to hide this from being in factored form is to put this in standard form and then trade with a partner and try to factor. So x times x is x squared, and then plus 3 times x, so plus 3x, plus another 3x, so plus 6x, and then plus 9.